So, my name's Camron. I work with Mainframe. I work out of our Salt Lake City office. We try to work very closely with the Swarm team, and we have for quite a while now. So, when I first joined Mainframe, one of the first things that I was tasked with was making it a little bit easier for the developers. We build a platform for building dApps. We try to make it easier to build dApps, and we use Swarm as a backend for that platform. And when we would hire on, JavaScript and front-end developers, it would be, fairly hard for them to kind of come up to speed and be able to run Swarm and get things running. And so I was tasked with not only trying to make it easier for our new developers to just be able to use Swarm without, too much ramp-up time. And through the process of working on that, we decided that we would really like to contribute something back to Swarm. And we decided to do that in the form of providing a bunch of Swarm nodes, contributing to the network. And so we provide some fairly beefy instances, and those instances are included in the boot nodes. So they're in the code base, they're in the Swarm boot nodes. But we also do a setup very similar to what Anton just presented, where we're doing containerized Kubernetes Swarm deployments. And when I saw the schedule and I saw that I was presenting after Anton and maybe presenting the exact same thing as Anton, I tried to make this a little bit fluid. So it won't be the same stuff. So what I'm going to focus on is just trying to walk you through and help you understand how you could also use the Helm charts that Anton has built and deploy Swarm nodes and contribute back to the network yourself if that's something you can do. So we're just going to cover the tools we're using, which are very, very similar to what Anton's doing. We may or may not need to cover why infrastructure as code is a good thing. I think everybody in here understands that. We are using, if we take a step back from what Anton just presented, so before Kubernetes comes into the picture, we're using a tool called Terraform. I don't know if you're familiar with it. It's a tool built by HashiCorp, and it essentially allows you to automate your infrastructure. So, in the good old days, you would have actual people racking servers and setting things up, and there was not a lot of automation in the hardware space, right? Cloud providers changed that a little bit, and taking it a step further, we're describing all of our resources just in configuration files and using Terraform to spin those up. So we really have almost zero, human intervention in deploying a set of Swarm nodes. So we'll just cover Terraform, help you, learn how to set up Helm and Tiller in a fairly secure default manner, and then installing the Helm charts that are built by the Swarm team here. So first of all, you're going to need Terraform. It's free. The AWS CLI, if you don't already have that, it's just a command line tool that allows you to programmatically access your AWS. You need kube control, Helm, and Tiller, and that's it. I already covered what Terraform is, and actually I'm going to show you a little bit what that looks like. So Terraform just uses a JSON-like structure. They're just using HCL to describe their own configuration language. Terraform also supports JSON just natively. Like, you can describe this in pure JSON if you really want to. And we're using AWS, but Terraform is provider agnostic, so whatever cloud provider you're using, even if you're using custom in-house solution of some kind, Terraform will allow you to automate all of your infrastructure. And you just describe it in these files. If you look here, depending on how familiar you are with AWS, we're doing everything from setting up EKS, which is Amazon's managed Kubernetes, to describing all of the roles and the policies, the auto-scaling groups, everything. I do absolutely nothing manual to spin up any of these Swarm clusters. Terraform is really easy to learn. Our Terraform files here are open source. You can find them at the Mainframe HQ GitHub account. So you could check out this repo, and all of our Terraform setup is in this repo. as well as our own Helm charts. Before Anton was finished with the Kubernetes stuff for Swarm, we had also built this before that was open sourced and ready. I have since actually started trying to migrate over to use what Anton has provided. So we're sort of in the middle of that process. We do have a few slightly different things. So I wouldn't recommend you actually use our Helm charts in here. I would recommend using Anton's, but you could use this Terraform stuff to spin up everything you need to deploy the Helm charts that are provided by the Swarm team. And so you just describe all the resources you need. And then it takes a while for AWS to actually like provision EKS and provision auto-scaling groups and stuff. So I just kicked off one. I started spinning up the infrastructure, I think in Paris. And let's find out how close it got to being done. Well, it failed, but this is what it looks like if it doesn't fail. So you'll just run Terraform plan. There's two main commands in Terraform. Terraform plan, which will create an execution plan and basically do a dry run. So it'll spit out exactly what's going to happen, what it's going to do to your AWS instances, and after that you can run Terraform apply. And you don't have to run plan, like you can just run Terraform apply, it'll create the plan, it'll run it, and it spits out, just all the information. It tells you what it's doing. Like right here, it's saying I'm creating your security groups. And after 10, 15 minutes, you'll actually have the infrastructure you need to use Kubernetes and deploy the Helm charts that are provided by the Swarm team. So feel free to check out that repo and use these Terraform files to spin up your resources that you need. And I'm not going to worry about why it failed. I think I may have already had things on the Paris instance. So if we move back. All right. You need the AWS CLI. Most people probably already have that. You just need it there. You need it configured. It's not hard. Read the documentation. Kubernetes. So we're using EKS, like I already mentioned. You don't have to use AWS. You don't have to use anything in particular. You just need a Kubernetes cluster somewhere. EKS makes it really simple, takes a lot of the overhead away. And then you just need kube control. Kube control is just the command line interface that you run locally on your machine to interact with your Kubernetes clusters. Helm, which these guys covered pretty well. Helm, it works with Kubernetes, and it allows you to it's a more powerful way to use Kubernetes charts. It allows templating. It makes it so you can reuse a lot of the things you build. You can think of it kind of like an application package manager for Kubernetes. So it's what makes it really simple for Anton to provide these Helm charts, and you can check out that repo and provide whatever values you need as inputs and just reuse that code. It's just a great tool for infrastructure management. The other part of Helm is a tool called Tiller. And Tiller is the part of Helm that basically manages your releases, like it manages the installations. A lot of times you'll see, and I think if you read through like the default documentation for Helm, it kind of has you set up Tiller in your Kubernetes cluster. I don't recommend actually running Tiller inside your Kubernetes cluster for security and role-based access control reasons like that. What I would suggest is whatever machine you're using to run your Kubernetes commands, run Tiller there locally in its own namespace, and that'll allow you to give different access to different secrets, and it also secures that Tiller server. So to set up kube control for EKS, in the AWS CLI tools, there is this command right here. This is in our documentation, these slides will be available, but you're just going to run AWS EKS update kube config, and basically what that does is it creates your local kube config file, and that is telling your local kube control where your cluster is and how to get access to it. This command right here just automates that. You don't have to monkey around with it too much. That will set you up and give you access to the AWS resources you just created using Terraform. Then you run the Terraform plan, which will do the dry run, show you any errors you might have, like I just had. And then Terraform apply actually runs it, creates the AWS resources. One more thing that I kind of automated is the config map, which is just some directives for Kubernetes and AWS, just telling all of your worker nodes and everything. It allows them to actually communicate on that network, on that VPC. So in our Terraform files, you'll find this config map AWS auth directive. And if you just run Terraform output, it will actually spit out the YAML you need for you, which you can then use kube control to send up to the cluster using kube control apply. And that's going to make it so everything that you have deployed it for the Kubernetes resources, they'll start, you can actually watch them, and that's this other command I've set here, the get nodes watch. You can actually sit and watch all the nodes actually start communicating and join, and you'll know that everything's working out for you. Helm and tiller, I'm not going to get into the deep details. This isn't really about how to use Kubernetes as much as it is how you can contribute to Swarm. If you're on Mac, Kubernetes Helm exists in Brew. And here, this is what I was talking about, running a more secure tiller. Providing a different namespace by default, tiller's going to deploy into the kube system namespace. But that basically gives everyone admin access to any secrets that Kubernetes is managing. If you put it in its own namespace, it allows you to give individualized access to whatever secrets might be needed. Then, since we're running this locally, we're just going to tell tiller that it's running in the tiller namespace. So just export that, put it in your bash file, do it manually every time, whatever you need to do. And then I like to start tiller locally or on the jump box that is running kube control for us. So we start it up, and if we look, I've got one running here somewhere. This is tiller. So I've got the tiller server running locally. I'm sending the logs just to standard out so I can watch things happen as I make changes, as I apply changes. So tiller's running there, just purely for security purposes, peace of mind, and that's just my opinion. Then you want to Helm, you're just initializing Helm, and then one of the first things you'll usually want to do after you've first installed Helm is just to update the repo. And I don't have it in the slide, but the next thing you would want to do is go and add the Ethersphere Helm charts repo as well. Kind of covered this, but don't run, I really recommend not running tiller in your Kubernetes cluster. So if you're using the Swarm provided Helm charts, you'll see that you need, one of the commands you'll need to run is Helm dependency update. So when I first built our own Kubernetes and Helm charts, I was individually installing Jaeger. So I would use a Jaeger Helm chart, and we would install Jaeger, and then I would install Grafana. And so they were just kind of individualized steps. I didn't include everything in the Helm charts, but these guys have actually added Jaeger and Grafana as dependencies to their Helm charts. You don't have any extra steps, but you'll just check out their code, run Helm dependency update, and it will install those other Helm charts for you into that project. And you'll see those when you look in your project. So under your Swarm here, this is where any dependencies you have will show up, and you'll see that I've installed the dependencies provided. You've got Grafana, InfluxDB, and Jaeger, and so that's just giving your local Helm the tools it needs to deploy with Kubernetes. We deploy ours into just a different namespace. We deploy everything in the namespace Swarm. But once you've run the Terraform plan, your resources are ready, you've got the swarm Helm charts installed, you've got their repo installed into Helm, all you have to do to run your swarm cluster is Helm install swarm cluster. When you run that, this is just the very beginning of what it's going to do. In fact, we can probably run this in like a live example. So let's do it. Yeah, all right. So I already deleted this stuff. So we're going to just do. All right, so we'll just run that command. Depending on how long the network takes, we're going to have a swarm cluster running here in just a second. We'll come back to it though. And then there's some great kube control tricks that will do all kinds of nice things for you, including just SSHing into any particular swarm node you deployed. So I've just provided this here. So once you've deployed it, you can connect to a swarm node and see what you've got going on. All right, this will eventually finish and we'll look at it. It's just having a slow network problem here. Oh. And that is about it, unless there are other questions. So if you go check out our repo or follow through these slides, every single step you need to take in order to deploy an EKS cluster automatically just through automation, and then use the swarm provided Helm charts and run your own swarm cluster, it's all there. And when I talk to a lot of different people, people get a little bit intimidated by Kubernetes in particular. And there is a little bit like of an initial learning curve with Kubernetes and understanding what it does and how it works. But once you get the hang of it, and when you're using recipes like this and charts that are already built by the Swarm team, it really becomes, you know, a 20-minute project to actually deploy and run your own Swarm nodes with tracing and metrics, which are great. So I'm hoping that with Anton's work and with the tutorials and the Terraform files that we provided for you, that more people will find it a lot easier to contribute back to the Swarm network. So we'll check back in on that deployment in just a second, but if you have any questions, I will try to answer them.